Welcome to the Explainer. So, I want you to imagine the sheer panic of thousands of concurrent users absolutely hammering your e-commerce site during Black Friday. Every single millisecond counts. And every price, it needs to be perfectly accurate. Today, we're diving into a really fascinating architectural case study from the AWS architecture blog. We're going to look at exactly how Samsung completely dismantled their legacy infrastructure and shifted to a lightning-fast, stateless streaming setup on AWS, all to achieve real-time pricing at a truly massive scale. If you've ever, pulled your hair out over caching nightmares or latency bottlenecks, you are absolutely going to love the elegance of this solution.
Okay, so here's our roadmap for today. We'll quickly cover the real-time pricing problem, the data aggregation trap, the stateless streaming solution, 3 implementation steps, 4 phases of optimization, and finally, resilience, scale, and security. Let's jump right in. Section 1, the real-time pricing problem.
So, what actually causes cart shock during high-traffic events like Black Friday? We've all been there, right? You're browsing a packed product page, you see a great flash sale, but then you click through to checkout and the price is mysteriously higher. It's frustrating. That inconsistency erodes customer trust instantly. And the crazy part? This isn't even broken software. It's actually a symptom of architectural latency.
It all comes down to something called the desynchronization gap. You see, to keep their really complex product pages loading quickly, Samsung was relying heavily on asynchronous caching. But here's the catch. Any intermediate layer that stores data is eventually going to diverge from the source. The second your cache drifts from your authoritative pricing engine, you've created a desynchronization gap. Basically, your customers are looking at the past.
Moving on to Section 2, the data aggregation trap. Originally, to decouple the front end from their heavy back-end pricing engine, which is the absolute source of truth, Samsung built this data aggregation service. They relied on everyone's favorite digital duct tape, a scheduled cron worker. But it only ran once an hour to fetch the product catalog. So the result was a massive 1-hour desynchronization gap. If a flash sale went live at 12:15, well, customers wouldn't actually see it on the main pages until 1 o'clock.
But wait, the lag wasn't even the worst part. The biggest issue was the computing waste. The math here literally creates an exponential nightmare. To make that hourly cache function, the system had to precompute prices for every single possible permutation of products. Imagine a page with 30 products. Now multiply that by all the color variants, then multiply it again by special offers and again by add-ons. It's like a giant impossible puzzle. You end up with thousands of precomputed records just for one single page. This storage cache just grew totally out of control. And honestly, the vast majority of those combinations were completely wasted because customers never even asked to look at them.
All right, Section 3, the stateless streaming solution. So how did they fix it? They completely tore down the old cache and adopted a pass-through pattern driven by a real-time bulk arbitration engine. Here's exactly how the new flow works. First, the client browser makes a single GET request for up to 30 specific SKUs. Second, an AWS Lambda function grabs this request and instantly fans it out to the authoritative pricing engine in parallel. And third, and this is the crucial part, as the pricing engine returns that data, Lambda streams it immediately back to the client. There's no buffering, no waiting around for all 30 items to load. The whole thing is completely stateless.
Let's dig into how they actually built this in Section 4, 3 implementation steps.
Okay, shifting to this architecture meant overcoming some pretty serious constraints. Step 1 is all about the streaming handler. A traditional request-response pattern would just buffer the full response, wait for all 30 items, and completely destroy any latency benefits. Instead, Samsung wrapped their Node.js Lambda handler in this incredibly useful AWS feature called AWS Lambda Streamify Response. They paired that with NDJSONTransform, which basically converts the pricing objects into newline-delimited JSON. So what does that mean in plain English? It means the browser gets to parse and render each individual price on the screen, piece by piece, the exact millisecond it arrives. Now, step 2. This is arguably the most clever engineering trick in the entire case study. Normally, to ask an API for 30 specific products, you'd need a pretty large post request. But CloudFront, like most CDNs, doesn't cache post requests by default. So to get around this, the engineering team brilliantly compressed their 4 kilobyte JSON payload into a dense custom query string. They made it fit perfectly into a standard GET request URI, keeping the whole thing under 800 bytes. That little unlock right there is what makes the entire system cacheable. Which leads us perfectly into step 3, configuring Amazon CloudFront. Now that they're using GET requests, they were able to set up a really precise cache policy. They gave it a 5-minute time to live, or TTL, and this 5-minute window is just the perfect sweet spot. It perfectly balances lightning-fast edge efficiency with highly accurate, fresh pricing data. Plus, by throwing those dense query strings into the cache key, every unique combination of products gets its own correct cached response. Section 5, 4 phases of optimization. This part is an absolute masterclass in tracking down bottlenecks. They completely transformed their P90 latency, which is the response time experienced by the 90th percentile of users. Starting out in phase 1, their baseline was a really sluggish 4,500 milliseconds, mostly because traffic was routing through a global VPN, which causes massive connection overhead. By moving the Lambda inside an Amazon VPC peer directly to the pricing origin, they slashed that time. Then, down in phase 3, adding HTTP/2 multiplexing and gzip compression dropped it all the way to 218 milliseconds. And finally, phase 4, turning on that CloudFront edge cache, brought the P90 latency down to a blistering 50 milliseconds. Just let that sink in for a second. From 4,500 milliseconds down to 50 milliseconds, that is literally a 90 times improvement in latency over their baseline. We're talking real-time, instant pricing rendered directly to the user without the system breaking a single sweat. But, the speed is honestly only half the story here. The efficiency is just as staggering. Thanks to that clever GET request compression and the 5-minute TTL we talked about, Samsung achieved a 95% cache hit ratio. Think about what that means. During a peak event like Black Friday, only 1 in 20 requests actually has to wake up and invoke the Lambda function. The other 19 serve directly from the CloudFront edge location right next to the customer. It's millions of requests served at edge speed, which keeps compute costs beautifully low. Finally, Section 6, resilience, scale, and security. Speed is amazing, right? But what happens when things inevitably break? Well, this architecture handles failure incredibly gracefully through 2 very deliberate constraints. First is that hard limit of 30 items per request. This isn't just some arbitrary number. It ensures the Lambda execution time always stays under 5 seconds, which prevents a cascade of timeouts during huge traffic spikes. Second, graceful partial failures. Because they stream the response via NDJSON, if the pricing engine throws an error for just 1 product out of the 30, the whole stream doesn't crash. The browser still gets and successfully loads the other 29 products, so the user just sees a mostly complete page instead of a glaring error screen. The real business impact here is just massive, and it's perfectly summarized by this quote from their engineering team. By completely ditching that heavy, stateful data aggregation cron job, their operational footprint practically vanished. Their compute fleet shrank from over 100 auto-scaled instances during peak events down to just 5 to 10 Lambda functions. That is a game changer for reducing maintenance overhead and operational costs, all while delivering a vastly superior experience for the customer. So that leaves us with a pretty big question to wrap things up. Think about the APIs you work with every single day. What are your highest latency aggregation endpoints? Are you maybe relying on a clunky middleware cache right now that forces you to choose between data freshness and scale? Could you compress your request data into a GET request and utilize this exact pass-through streaming pattern for your own product catalogs or inventory systems? It's definitely a powerful challenge to rethink exactly how we deliver data. Thanks so much for joining me for this explainer, and I'll catch you next time.